Hello guys, welcome back to my channel. In this video we are going to discuss regarding the set problems. Okay, so I find this problem or this question is quite challenging, but it is not that difficult. Alright, so let's get into the question. So given that A and B are two events with the following probabilities, so you can look over here. Find the probability of A intersection B. Hence, determine if A and B can happen together. So you need to give the reason why. So first you need to know what is mean by can happen together. So I will introduce you with the concept or with the term of mutually exclusive or mutually inclusive. Mutually exclusive and mutually inclusive, alright? So for the first one is mutually, let me use bright color. So for mutually exclusive, okay, mutually exclusive. So mutually exclusive means that the event, for example event A and B, cannot happen together or cannot happen at the same time. Okay, so like this. Okay, so for example this is A and this is set B. So this is set A and set B. So set A, if set A happens, then set B will never happen. Okay, so they have no intersection, which means that P, probability of A intersection B, is 0, so no intersection between them. But for the case of mutually inclusive, so mutually inclusive means not mutually exclusive. So this means that the event A and B can happen together or can happen simultaneously. For example, like this, right? So this is A and B. So if you see that in between them there is an intersection, so this is intersection. So A and B is possibly can happen simultaneously at this intersection, which means that P A intersection B is not 0. Okay, so referring back to the question, we need to show either P, probability of A intersection B, is 0 or not 0. Okay, if 0, then the event is mutually exclusive, else the event is mutually inclusive. Okay, so let's get into the question. Because we are given PA is 2/7, probability of A is 2/7, and probability of A given B complement is 3/7. Probability of A and B, probability A union B is 43/63. 43/63. Okay, so we need to find P, probability of A intersection B. First, let's use the fact of this PA union B is basically P. So first I want to assume that the event is mutually inclusive, so I use the formula for the union of the mutually inclusive event is P, probability of A, plus probability of B minus probability of A intersection B, like this. Okay, so let me substitute the value. So this one is 43/63. Probability of A is 2/7 plus probability of B is not known plus probability of A intersection B is also unknown. Okay, so let me set this as equation number 1. maybe we can tidy this up. So I will simplify this. I will bring to the left hand side, so it's minus 43 over 63 minus 2 over 7 is 25 over 63. Okay, so I will erase this. Becomes 25 over 63. Okay, so that's just the matter of simplification. All right. Okay, so this is equation number 1. Okay, so let's find equation number 2 from this expression. Okay, from this expression. Okay, from this expression. So we know that P, probability of A given B naught, okay, is basically equivalent to, so according to Bayes' theorem, so this is equivalent to P A union B complement divided by P B complement. Okay, or it is also equivalent to, so we have two formula for this. Okay, according to Bayes' theorem is P B complement A P A over P B complement. But for the matter of this question, we are considering the first equation of this. Okay, the first formula I mean. Okay, so if you observe back this, the top fraction is probability of A intersection B. So probability of A intersection B, what does it mean? So it means that, okay, let me draw the Venn diagram. Okay, like this. So assume that A and B is mutually inclusive, which means they have the intersection over here. So for example, this is event A, event B. Okay, so event A and event B are mutually inclusive, so I assume. All right, so where is the region A intersection B complement? So the region is here, right, over there. So A intersection the B complement, which means does not include the B. Okay, does not include the B, is over there. So the intersection is over there, right? So this means that this this region is actually probability of A only. So this part A only. Okay, A only. Okay, but if you consider this whole part is actually P of A. Okay, P of A. But if we exclude the intersection part, which means this is A only. Okay, A only, right? So that's the logic behind. Okay, so we know that we can substitute our Bayes' theorem formula with probability of A only, like this. Okay, and we know that the complement of B is basically 1 minus PB, like that. Okay, that's the same thing. Okay, A only. So what is A only? So A only is basically probability of A minus the probability of A intersection B. Okay, so how it works, so it's like this. So for example, this is A and B, so we want to find this part. So probability of A, which is the whole thing, this one, you minus with the intersection part, this part. So if you minus the whole A minus the intersection part, you will get only the only this part. Alright, you will find this only this part, the yellow part, okay, which we are desired for, right? Okay, so let's substitute in the value. So probability of A given complement B is 3/7. Probability of A is 2/7 minus probability of A intersection B, 1 minus PB. So this is equation 2. So let's tidy up the equation 2 first. How can I tidy this up? So it's 3/7, sorry, 3/7. So I will bring this denominator to the left hand side. I multiply it, minus 3 PB over 7 is 2/7 minus P A intersection B. So let's simplify this. So I have simplified the equation, so it becomes like this. Okay, so we have, from equation 1 we have this. So we have two unknowns and two equations, so we can solve this very easily using simultaneous equation. Okay, so equation 1 and equation 2. So I am interested with the intersection between A and B, right? So I need to eliminate this probability of B, because the question doesn't ask us for the probability of B, right? So let's eliminate probability of B first. So I can do this by subtracting. I can subtract them, equation 2 and equation 1. Okay, so I already subtract equation 1 and equation 2 together, so I get this. Okay, and then we just divide both sides by 4/3, so I get probability of A intersection B is 4/63 minus 4/3, which is 4/63 minus 4/3 is, I get what, 1/21, is it? Wait, let me check. Yes, it's 1/21. Alright, so we get it is 1/21, right? So for question A, for question A, to find this intersection, hence determine if even A and B can happen together. So looking back at our notes, so this is our notes, right? So we say that if the intersection between the sets, sorry, not the set, between the events, okay, we can say it's a set because this is the Venn diagram. So the intersection of A and B is 0. If that happens, then it is known as mutually exclusive. But if it is not 0, it is mutually exclusive. From our answer, the intersection is this, which is not 0. So it is non-zero. Hence, maybe I can say it's like event A and B are mutually inclusive, which means they are possibly occurs or happens, I could say, happen at the same time, right? So this is our answer. Okay, so give the reason. I have been given the reason. Okay, I've been giving the reason over there, and also the calculation includes, right? Yeah. So alright, so I think that's all for the this video, and yeah, until next time, and I hope there is no problem with my explanation, with my writings, with my handwritings, and with my the way I'm talking. So I hope everything is fine and everything is understandable. So yeah, thank you.